All right, so today we're going to talk about the science of sleep and what is actually happening in your brain when you sleep. The sleep cycles, the different parts of your brain that are active and at rest, the chemicals that we use during sleep, and how your body adjusts to this clock. Thank you so much, Mary, for giving us the details and the research on this.
Yes, absolutely. Well, you know me, I love to talk brains. Okay, so first let's define what even is sleep. So sleep in humans, it's it has an interesting long title. Like listen what it is. It's complex, it's reversible, it's a behavioral state where an individual is perceptually disengaged from and unresponsive to their environment. Like it's so bizarre when you think about it, right? But we do it every night. We've done it since we were babies, so it's okay. We got this. And good sleep is characterized by, satisfaction that you feel good after you had a good night's sleep, appropriate timing, adequate duration, high efficiency, so it helps you feel better the next day, and it leads to sustained alertness during your waking days. So that's how we know when sleep is going well, all of those things. So it has to be satisfying, appropriate time, adequate duration, high efficiency, and sustained alertness, so you feel good, you're not falling asleep all day long. So sleep can be broken down into 4 stages. One of them is called non-REM sleep, and then light sleep, a little deeper sleep, and then REM sleep. And all night long, we cycle through 1, 2, 3, 4, and back and into deep REM, and then back through, and then we sleep again into REM. So all night long, we're in multiple brain cycles. And during the different cycles, we actually have different things happening to the body. So in stage 1, or non-REM sleep, it's when we're changing from being awake to sleepy and very lightly sleeping. So it's pretty short, it's a couple minutes, and our heart rate changes, our breathing changes, our eye movements slow, our muscles kind of relax, but sometimes you get those muscle twitches. Did you ever have those when you fall asleep? You're like, all of a sudden your leg goes. Then you know, oh yeah, I'm in stage 1 sleep. And then stage 2 is also non-REM. There's 3 non-REM sleep periods, but so you go from stage 1 is pretty quick, and you might have some muscle jerks, into stage 2. Again, your heart rate, your breathing slow, your muscles relax, your body temperature starts to drop, and your eye movements, your eyes don't move anymore. So sometimes if you've ever kind of checked on someone to see if they're sleeping and they're just kind of staring there, they're sleeping. And your brain waves will change during this as well. And then in the third, it's another non-REM, but it's a little deeper sleep. And you actually need a lot of this to feel good in the morning. So if you don't get to stage 3, you keep getting woken up from stage 1 or 2, you don't really feel very good in the morning. So you need to be in stage 3 for a little bit. And as you cycle through these 4 periods, you have more and more of stage 3, and you have your lowest heart rate and your lowest breathing during this time, which is interesting to think. It's not even something we have to think about, right? That's why the brain is so amazing, because there's multiple brain parts associated with sleeping. So we'll go over that a little bit, but your brain waves are pretty slow at this time. And then you go into REM sleep, and that usually is about an hour and a half after you started in stage 1 sleep. And your eyes move rapidly back and forth. That's why it's rapid eye movement. And you have a different kind of brainwave activity during that time. And your breathing actually picks up a little bit. And sometimes it's even kind of irregular. Your heart rate goes up too. So it's slow. It slows all through the first 3, and then it kind of picks up during this time. And believe it or not, your arms and legs are paralyzed from a certain part of your brain so that you don't act out your dreams. Because I certainly have had dreams where I'm riding a bike or I'm running, and you don't want to be acting that out in your house when you're not aware. So it is interesting that we are paralyzed every night in sleep. It's such a strange concept. And as you get older, you need less and less REM. And that's actually a time when we're laying down new memories. So they call it memory consolidation. And we need that during non-REM, but we also need REM to consolidate our memories. And there's a lot of what we will call neurotransmitters involved. So those are the chemicals that the brain shares with other parts of the brain. Some of them are called GABA, acetylcholine, et cetera. And those are very active during this time, during these different kind of stages of sleep. So we have stage 1, 2, 3, and then REM, and we cycle back through all of them. Usually we cycle through about 4 to 5 times a night. So we need a lot of the stage 3. Yeah, I know, it's interesting. And there's many different parts of the brain that are involved when we sleep. So this is the forebrain, the front part of the brain. And underneath that, we call the basal forebrain. That one helps us stay awake. It also helps link to what we would call the brainstem, the part of the brain that leads down into the spinal cord. So there's multiple parts of the brain that are involved with sleeping, including our eyes, right? So our eyes, if we sense light, that wakes us up. And we don't, it's not even something we think about. So as you can imagine, we don't turn on these chemicals willingly. Our brain just handles all of this for us. It handles moving us from stage 1, 2, 3, 4. So that's why we need to kind of tap into our own power that we have, that our brain has a whole system to do this, but we can disrupt the system by certain ways, by, you know, not going to bed till 3 in the morning or drinking lots of alcohol. There's ways that we can disturb this, which we'll get into a little bit more later. So the parts of the brain that are involved, the base of the front part of the brain called the forebrain, that is linked to our brainstem back here. It's also linked to our hypothalamus, which is kind of behind your cheeks, kind of this trajectory, that has a lot of our emotions there as well. The brainstem is the part that paralyzes us. That's the part that leads down into the spinal cord. And there's also something back there called the pons, is part of the brainstem. And that also then reflexively sends information back up to the front to have a whole system. So it's almost, I think of it like an orchestra, like you have the cellist and you have the violin and the clarinet, and when they all come together, they make this beautiful sound. But you know, alone, they're all doing their own thing, and they're all connected. So there's networks between all of these to help us know when we should wake up and when it's time to go to bed. And there's the cycles, as we heard about, that we cycle through a few times, 4 to 5 times each night. And we have, you know, all different chemicals that we talked about. Let's go. We also have something called the thalamus, which is a center where a lot of our information, our thinking and our movement pass through. So that's deep in the brain. And it's like a relay of information, from a lot of information coming from the cortex, the outer part of the brain. So during most stages of sleep, it's very quiet so that it lets you tune out the external world. But during REM, it turns on. And so that the thought is that during dreams, it kind of turns on so you can envision, you know, different images that we know as dreams, which is interesting. We have a little gland in the back of our head called the pineal gland, and it receives signals from various parts of the brain, and it produces the hormone melatonin that sometimes we go to the drugstore to buy to help us sleep, but our brain makes it naturally. And it helps put us to sleep as long as the lights are down. So if you take melatonin and you stay on your phone, it's probably not going to work very well. Melatonin works when the lights go down, and that's what your body naturally does. So that's why it is important to have lights, to know that lights are a cue for you to either stay awake or go to sleep. It is interesting that people who lose their sight and don't have any light perception sometimes will have trouble with waking and sleeping cycling, because they lost the input that our brain naturally has to keep us awake in the light. As long as they have a little bit of light perception, they don't lose that, which is interesting. So melatonin over our circadian rhythm. So a circadian rhythm is our 24-hour cycle that naturally happens according to light and dark. And the melatonin kind of follows that cycle. So there's a lot of chemicals, a lot of different parts of the brain that are involved. And also our amygdala is involved. And we hear a lot about amygdala with like fight or flight. It's our emotional center. It's our center that makes us feel nervous or anxious. But it's actually involved in processing emotions, and it becomes more and more active during REM sleep. So that's another theory of why maybe we remember some of our dreams, and dreams are linked to our emotions of our day before us. So all of these chemicals, you know, this is the orchestra of sleep. And, you know, when we think about dreaming, you know, the dreams, sometimes you don't remember them, but sometimes the estimate is that you dream a few seconds up to 2 hours every night. And then sometimes you will remember them the best if someone wakes you up when you're in REM, because you were right there in your top dreaming stage. And everyone dreams, they say, even though, because some people say, I don't dream. I never remember dream. I don't dream. It's just that you weren't woken up by REM or you don't remember them. But generally the estimate is everyone dreams about 2 hours every night, and you don't remember most of them. And we don't really know why we dream, but one of the concepts is that maybe it does help us process our emotions or activities of the day, because they do see that the centers of emotions actually light up during dreams, which is interesting. And you can dream in all stages of the sleep, but they're most vivid in REM. So that's when if someone wakes you up right when you're in REM, you still think you're riding a bike or, running down the street and they just got you out of a good dream. And some people will say they only dream in black and white. That might be true. We're not really sure about that. So the average healthy adult gets, about 1 to 2 hours of deep sleep every 8 hours of sleeping, which is fine. That's what you need. You need deep sleep for your body to repair. For a lot happens during sleep that really is beneficial to the body and the mind and emotions and your thinking and your memory. So many things.
And your focus, your productivity, right?
And your focus and your productivity. So how do we align with those natural clocks that help us fall asleep? We call it winding down. How do you wind down according to what nature has inside of us, all those chemicals and the orchestra that's working? So we have two systems, internal systems that let us know when we should sleep. So one is that circadian rhythm. So that controls the timing of your sleep. It causes you to be sleepy when it's time. And it generally will synchronize with your environment, like light and your temperature, the temperature that you're in, or your temperature. And then there's also a sleep wake, they call it homeostasis, which reminds your body to go to sleep, and it regulates your sleep for you. So the more you're awake, it's almost like a clock counting down, like you've been awake 10 hours. I'm going to make you feel tired soon. You've been awake too long. So you have these two internal systems that are letting you know that it's time, I need to go to sleep, and it counts your awake hours, and your drive to sleep gets stronger as your awake hours count down. So you have to listen to both internal clocks. And the way to listen to especially the circadian rhythm or your circadian clock that is telling you to wind down and get ready for bed is your body will get cold. And that happens, you want an extra blanket, you want to put socks or something cozy on because you're getting cooler, because that's your circadian rhythm and all those chemicals that we talked about getting ready to prepare you for that night's sleep. And that's the beginning of your sleep onset. So that's actually when a neurochemical called GABA, those nerves are turning on, and there actually is a bit of a sleep wake switch. So it's like the brain time to sleep, and then all these chemicals will turn on and the orchestra will turn on to get you ready to sleep. Your body temperature increases in the morning. So that's sometimes what wakes us up is just simply our body temperature, that we're getting a little bit warmer. So it starts to go up around 6 or 7 in the morning, and it triggers our awakeness and our alertness. And that is when the sleep GABA neurons are quieting down and letting kind of that sleep wake switch kind of turn on to more awake. If you're trying to wind down and to go along with your circadian clock, you want to avoid light, because this will suppress your melatonin, and melatonin naturally will increase about 2 hours before you're supposed to go to bed. And that's your circadian pre I'm ready to go to bed state. Meals, you want to eat regularly, but you don't want a lot of glucose right before bed, because that will change some of the neurochemicals that are high or low. And it'll tell your body it's more of a daytime activity. So you want to be careful of nighttime snacks, that they're not too big or they don't have a lot of sugar in them. What else? So let's go over just a few tips. So some tips with what we just reviewed. Number one, that there's multiple parts of the brain involved. It's an orchestra. And so we need to go along with our natural circadian rhythm so that we can let our orchestra work how it's supposed to. So it's really helpful if you set a schedule. If you're going to exercise, it has to be a few hours before bed. Generally, that's best, because that also turns on some of the neurochemicals that are not sleep chemicals. You want to avoid heavy meals before bed. Avoid caffeine and nicotine. Late in the day for sure, nicotine, hopefully always. And alcoholic drinks before bed totally mess up the sleep switch, the on-off switch, because it never lets you go into sleep. It just stuns the nerves, and then they wake up at 3 in the morning. You want to relax before bed. A lot of people like a warm bath or reading or, light yoga, stretch. That helps to calm down without screens, and create a room for sleep. And your room should not have bright lights. It shouldn't have loud sounds. It shouldn't have screens. It shouldn't be where you do stressful activities. So it shouldn't be where you pay bills and things. And if you can't sleep, don't stay in bed for hours. You should get up after 30 to 60 minutes and try to reset that clock. That can happen naturally. And obviously, this is all educational material. See your doctor if you need any help. This is for education and to improve your work productivity and focus, which all of this can. So that's pretty neat. You know, that's a really impactful way to have better days at work, is to learn about sleep and then to learn how you can optimize it. So I hope this is helpful. Allie, what did you get from all of this?
Yeah, no, that was so helpful. I think that the biggest takeaways are really understanding like why and how sleep is so important and actually how many parts are involved. We think it's not a big deal to stay up a little bit later or to kind of mess with our body's clocks. We're actually messing with two clocks. And
Yeah,
the chemicals are involved that, you know, there's a lot of chemicals involved. There's a lot of different parts of the brain that are involved. So I think understanding that is hugely important. And I'm excited to talk more about how we can plan better, how when you now everyone has trackers, we have iWatches and different trackers about, to talk about sleep. So understanding the cycles and how we move through them and what's most important is hugely beneficial, because I think sometimes we don't know exactly what we're looking at and what's all happening behind the scenes. So thank you so much for giving such a thorough and detailed explanation of what's behind the scenes. I think it's just amazing to understand how brilliant our bodies are and how our brains run the whole thing.
right. Amazing orchestra. Yes.
Yes.
So you have to honor the orchestra. Yeah, get good sleep. Let it do its work.
Yeah. Amazing.
Mm-hmm.